critical network service is silently running your business and allowing your employees to send emails, make VoIP calls, run cloud apps, and more. It's a mission-critical IT service called the Domain Name System, or DNS system. The DNS service is so vital today it's become a prime target and entry point for hackers and data thieves. As a matter of fact, 77% of companies face DNS attacks and suffered irreparable damage and loss. In particular, loss of business, application downtime, data theft, and more. Unfortunately, traditional security solutions such as firewalls, IPS, or anti-DDoS systems are not adapted to protect DNS services against attacks such as flooding the DNS server with a high number of requests, creating a low volume of specific DNS requests causing capacity exhaustion, or attacks exploiting bugs and flaws in DNS services or protocols. But there's an ironclad solution to protect your DNS services: the efficient IP 360-degree DNS security solution. 360-degree DNS security offers a new layer of in-depth defense to protect your public and private infrastructures against all attack types, from both external and internal threats. Efficient IP patented innovations ensure unmatched continuity of your vital DNS services, even during the most menacing and powerful attacks. The solution is fast to deploy, easy to maintain, and highly effective. Efficient IP. Secure your DNS. Secure your business.
Hello, good morning, everybody. My name is Donald. I believe I'm the last presenter for this session itself. So I will try to make it short and sweet so that I will not delay your lunch further after the panel session itself. Now, today we are talking about Metaverse, right? Metaverse is not the only thing itself, but Metaverse refers to what we define as virtual reality. And with all virtual reality, with all objects, you definitely require what we define as IP addresses. Now, how do we get IP addresses? IP addresses comes from DNS. When you do a lookup into the internet, that's where we assign IP addresses to your IoT devices, to your virtual reality goggles. And because in DNS, it's like your phone book, right? You will find all the telephones of all your houses, all your friends. And in the DNS space, in the DNS world, DNS will be the one that assign IP addresses to all your IoT devices itself. Now, the challenge with regards to DNS, and we did a survey last year together with IDC, is that 87% of organizations actually are subjected to DNS itself. And the cost and the average cost of a DNS attack amounts to about 950K, and that is truly a huge amount. And 76% of the organization that we have surveyed suffer at least application downtime, and that impact their businesses as well as their users. So 1 in 4 of the organization in the report that we have done suffer data theft, because one of the objectives which I will share and go through later with regards to DNS attacks is about stealing the data, stealing your crown jewel itself. And all is this, and it all resulted because of malware abuses that is embedded as part of your DNS services that is being offered, or you are hosting within your own premises itself. Now, as we search through the internet, right, with regards to DNS, what are the kind of DNS challenges that we face, that we see, what are kind of attacks that are available itself? So you will realize that there is a lot of denial of service, buffer overflow due to DNS, because you are not able to update your DNS vulnerability in time. You have web page vulnerability because due to cache poisoning, where you receive a link sent to you via a phishing scheme saying that, hey, this is to alert you that you forgot your password. Please click on this link so that you can change your password. But at the end of the day, it's being routed to hackers' databases where they will retrieve your password to gain access to your information. Then there are exploits within DNS servers, the OS that's being run DNS. Like for example, recently there's a zero-day bug that is uncovered in the library that leads IoT devices vulnerable itself. So let's look at what are the key reasons why hackers are targeting the DNS, and DNS today not only acts as an attack target, but it also attacks as a threat vector itself. Malicious hackers, they know that DNS is very, very critical for business services. Business services organization, regardless of what business you run, what service you provide, you require DNS to provide a service to your customer itself. It is a very key role with regards to application traffic routing. It links you between your user and application. In order for your users to access the application, DNS become part and parcel of your daily life itself. Now, second reason with regards to DNS is if you look into how it is being designed, it is open by design. You have customers using Microsoft DNS, you have customers using OpenDNS or other DNS that is available out there in the market today. So when DNS is open by design, it is subjected for hackers to exploit, to target, to create havoc within the organization. Now, this is something interesting whereby DNS is not effectively protected by what we have today in our perimeter defense, be it the like of proxy, be it the likes of next-gen firewall. I will share with you in detail why we say it's not effectively protected. Now, you guys might be taken aback saying that, hey, does it mean that what I have implemented in my perimeter defense cannot protect DNS? What we are saying today is that security is about layer of defense itself. And what you have today may not be the appropriate tool, may not be the appropriate device to look into DNS attacks. So cybercriminals actually mix of DNS as a dual role in the entire key change, whether as a threat vector or as a target attack itself. Now let's take a step back into this key point, why DNS is not effectively protected by the traditional parameters tools that you have in your environment. So if you look at how DNS typically provides service, DNS service typically relies on three different functions: authoritative, cache, as well as recursive. So there are a few ways as a user where you can retrieve your IP address or how you access your application itself. Number one is that from your laptop today, you can do a query to your DNS servers. And if the cache inside your DNS have the domain or the IP address, it will return the response back to your end user or to the client itself. Now, the other way is if the cache inside your DNS do not have the latest information, do not have the latest updates or domain itself, what will happen is that the cache will relay the request to what we call a recursive function within the DNS server. The recursive functions will basically identify the authoritative DNS servers for the requested domain, get the answers and relay it back to the cache. And the cache will be the one that will communicate the information back to the client itself. Now, why this fundamental knowledge of how DNS service is provided is very key, because what hackers or what cyber criminals realize is that the issue between the cache and recursive can create a gap, and that's where they will start to exploit, and that's where they will introduce several mechanisms to steal data or steal information itself. So if you look at traditionally how a typical firewall, right? Why we always say that the abnormal use of the cache cannot be detected by next-gen firewall itself. So imagine hackers that is embedded inside your client laptop wanted to make a DNS request itself. So the DNS request will be sent to your DNS server. The DNS server's request may not be embedded in the cache. So what will happen is that the DNS resolver will send a query to the recursive function, right? Remember in the previous slide, I mentioned about the purpose of the recursive, whereby you need to attempt to retrieve information from an authoritative server itself. This recursive function will go through the firewall that you have inside your company or in your data center itself. So through the firewall, you will send information to the authoritative servers. But because the firewall basically sometimes they only looks at the domain, they do not look at the client itself, hence that present a gap where the hackers would be able to steal the data because the malware that is embedded inside your client would be able to bypass your firewall if your firewall only looks at the domain but do not look at what we define as the DNS transaction that is from the client all the way to your authoritative server itself. So hence why we felt that, and it's important to know that potentially what you have today in your next-gen firewall or your proxy may not be sufficient to detect, to monitor DNS transaction that can be exploited by cybercriminals. So traditional firewalls or traditional devices, they do not, some of them do not have the capability to do what we define as DNS analytics that is based on behavioral threat detection itself. It can be very complex to deploy because the main function of firewall is basically looking at your domain, basically filtering of rules based on IP address, which one to allow, which one to deny. They may not have the capability to look into the entire DNS traffic itself. And because of that, you will introduce high risk of false positive. You might be blocking the entire domain, but potentially within that domain, only the particular client based on the DNS traffic needs to be denied or needs to be blocked itself. Most of the attacks are not proactive, right? Most of the devices that you have are unable to mitigate new attacks, especially when there are zero-day attacks being introduced itself. And some devices, depending on how it's being deployed, may not be able to handle volumetric attacks, as what the previous speaker has mentioned itself. So DNS Ddos attacks are one of the common things that we see nowadays due to the huge evolution, due to application slowly moving to a cloud, due to the aggressive transition to digital transformation itself. So what are the kind of DNS attacks that we are looking at today, or what we have explored across what we have encountered across the customer environment itself? So if you look into a typical cyber queue change, right? Basically, we look into how potential cyber criminals can do DNS recons, right? How do you look into where are the targets, where are the email addresses being resided at? How do you, where are the backdoors that is embedded through your DNS request? And after that, then you will need to decide, how do I deliver the packet, right? That malware packet into your DNS servers? How do we bundle it to the target, either via a phishing email, via a website, or even via USB. Now, all this cyber queue change, we are talking about using DNS protocol. We are talking about how do we target DNS servers and using that as a media or platform to penetrate into an organization itself. And how do we, after we have done the survey, recons, we have done identify where are the location to deliver the packet. And that's where you start to do installation of malware at your client, at your DNS server, or even at your application itself due to the DNS response. So that's where you will get DNS exploit. That's where you will get DNS hijacking, and through command and control, which is a very common function, command and control. That's where most of the cyber criminals are using today to target DNS servers, to control your DNS so that you will be manipulated, you will be forced to believe that you are making the correct query, and that's where data theft occurs itself. And last but not least, once a cyber criminal gains command and control, that's where you will encounter lateral movement within your network across other assets, across other devices and system itself. Because the ultimate goal of why cyber criminals make such an effort into the entire cyber kill chain is because they want to extract your data, use it to sell in the black market itself. And although they may be doing a huge DDoS attack, but it's the small attacks that they are trying to do onto your DNS to extract those data in order to sell it to your blacklist market itself. So if we classify the attacks, right, we classify the different kind of DNS attack, whether is it attacking the DNS or using the DNS as a medium to exploit your data itself. So if you look into the different category of how cyber criminals typically attack a DNS, it can be using volumetric attack, right, using DDoS as or DNS, the large volumetric attacks, and then subsequently using the stealth attacks to steal undercover, unnoticed into other services. And last but not least is exploit, right? What are the backdoors that are available in all these DNS services or protocol that allow cyber criminals to into how are attack scenario. So if we look into, like I mentioned earlier, CVE, there are really vulnerability out there with regards to how flaws or blocks DNS services. So if I will show you a demo on how this give you an idea how do they attack
Hacking demo number 5, Zero-Day Attack. The attacker will try to take control of a victim's computer using DNS. A malware is crafted, embedded in a document, and sent by email. The attacker only has to wait for his victim to open it. When the document is opened, the malicious code is executed and a command and control channel is created. This channel is relying entirely on DNS packets to transmit the data, and then the malware starts to propagate itself. In 2016, 11 critical bind vulnerabilities were disclosed. Some of them would allow just a single packet to make the service fail, as we are going to show you. The attacker has the objective of bringing down the DNS service so that the users won't be able to access their financial application. For that, he is going to send a vulnerability attack, targeting DNS server after DNS server. Using unpatched vulnerabilities, the hacker was easily able to successfully interrupt the DNS service. How it works. We are going to monitor at the same time both the DNS health and the availability of the critical financial application. As you can see, the service is up and running. The attack sent relies on a single crafted query. The impact is instantaneous. The service is now down, and the business applications will quickly show traces of failure. Most legacy security devices rely on threat signatures to prevent vulnerability attacks, but very often they arrive too late.
So that's how typically zero-day attacks happen itself. And if you move to the next DNS classification about using command and control, right? Using how cybercriminals typically use DNS as a transport mechanism to communicate with remote servers to control the remote servers itself. So one of the most famous way is really to use command control to do data as filtration, as well as to remote control your DNS servers so that they can basically perform lateral movement, as I mentioned in the cyber skills queue change, to extract data as well as confidential information itself. So let's see how they typically handle or do a command and control attack into your system.
Hacking demo number 2, command and control. The attacker will try to take control of a victim's computer using DNS. A malware is crafted, embedded in a document, and sent by email. The attacker only has to wait for his victim to open it. When the document is opened, the malicious code is executed, and a command and control channel is created. This channel is relying entirely on DNS packets to transmit the data. Although the session is outbound from the victim to the attacker now has entire control of his victim's computer and can send any command to it. How it works. The attacker is waiting for the tunnel to start, interacting with the infected computer. Malicious code is executed, the channel is created with the CNC. The attacker has entire control of his victim's computer and can execute any code. Without any access to the corporate network, the hacker has full control using DNS protocol. Most legacy security devices rely on threat signatures. They are blind and will not protect you.
So these are example, right, of how the two kinds of attacks, whether as an attack vector or as a threat vectors, and the combination of such attacks basically introduce a lot of challenges like DNS cache poisoning, hijacking, phishing. And phishing has been a very common topic that all of us are experiencing today, which we are trying to use education, trying to use awareness to educate our end users, our users to ensure that they do not click on suspected or emails or links that they do not know itself. And this is really how cyber criminals use DNS as a form of way to basically hijack as well as to steal data from unsuspected end user. So how do we overcome these DNS attacks? Basically, from efficient IP, we provide what we call a 360 DNS security itself. We provide both servers, virtual appliances that would be able to mitigate zero-day attacks, enforce best security itself. Right, we can secure internet DNS visibility, whether your DNS are being deployed at Azure or you're using AWS Route 53 or even in the cloud itself. We also have our DNS Firewall that protect users and block DNS malware activities and ensuring DNS availability to protect your data, whether it is volumetric DNS attacks, stealth, or even DNS exploit itself. And most importantly, we do have what we call a carrier grade that is being used by telco to handle DNS attacks, because DNS attacks is about doing large volume of query into your DNS servers as well as your application itself. Now, what is so special about our DNS 360 security itself? We have two different DNS servers, right? One is the standard binary servers itself. We also have what we call an NSD server. So we have two DNS engine in the same appliances. So at any point of time, if one of the engine, right, is vulnerable and it requires time to be updated, we can automatically configure, it will be automatically configured where the changes, the updates, the configuration will automatically be synchronized into the other DNS engine itself. So at any point of time, only one DNS engine is available at one time. So that minimizes downtime, that minimizes usability itself. We also have our own mechanism to ensure that there's no single point of failure. And most importantly, the way we are able to switch the DNS engine, it will help to improve network operation. It will help to ensure there is remediation agility itself. Now, within the same appliances, we have DNS Firewall that will be able to detect, monitor, and adapt protection into your DNS landscape. We also provide threat feed, or we can also input threat feed into our DNS Firewall to make sure that it's always updated, and it will be able to monitor and block any request, forbidden requests from the client laptop or system itself. Now, one of the key differentiator is within our DNS Guardian, which is also in the same appliances, same single box itself. You have what we call DNS transaction inspection, DTI, where we are able to provide real-time analysis of the client, right? Of the DNS traffic that goes from your client to our cache or recursive servers through our box itself. And we have patented this technology based on our behavioral based threat detection itself. And this is one of our unique differentiation where we are able to not only monitor the domains, but also monitor the source of the attacks, which typically comes from the client machine. Even when your client machine is being controlled by command and control malware that's embedded into the laptop itself. So we also, like I mentioned, we also have a DNS analytics that is embedded into the box, which most of the traditional perimeter defense firewall may not have the capability to do so. By analyzing your DNS traffic, it provides more visibility. It combined together with our threat intelligence, it will be able to help to detect zero-day malicious domains, as well as abnormality of traffic coming from the client or from your domain into your application itself. And last but not least, is about visibility, right? A single pane of glass that allows you to monitor all your DNS traffic, regardless of coming from AWS, from Azure, from your cloud platform, or even from your on-premise DNS server itself. So this single pane of glass will give you the most active or most used domains, what are the clients that are active itself, which are the domains that are not used, and this would be able to retrieve or detect abnormalities, and that will improve your threat detection rate. That will be allow you to do countermeasure that can be triggered for your SOC or for your engineers to react itself. So in summary, basically, DNS, regardless of whether it's Metaverse, right? DNS is really the key foundation of all internet traffic itself. So threat intelligence is the context. You need to have proactive and predictive security to detect zero-day attacks. As we evolve, as the internet evolve itself, as people start to move into digital transformations, it is very key to ensure that all these zero-day malicious domains can be immediately be detected and blocked, and all this locked information can be retrieved and seen from a single pane of glass itself. And this is where DNS security comes in. This is where efficient IP helps to monitor your cache, your recursive, as well as your authoritative DNS servers. And we can provide all this within a single devices with a single pane of glass and connect to your multiple infrastructure itself. So if you look at the cyber kill change that I shared much earlier itself, our DNS Firewall and Guardian will basically monitor help to monitor this from a delivery perspective itself. We will also do client query filtering in terms of what are the kind, whether is there any malicious malware that's being installed on your DNS servers, on your infrastructure itself. We will detect look into your DNS traffic through our DNS Guardian for any command and control channels through the DNS protocol. And most importantly, prevent data theft from exploiting or coming out from your network itself. So Metaverse is something that we really need to look out for, but most important thing is with regards to how do we help you to secure your business, and most importantly, how do we help you to secure your data? So hopefully, I provide a quick overview of what are the challenges that DNS security can do to your business itself, and how efficient IP can help you to protect your environment. So with this, I end my presentation. Thank you.